A bowling ball. I decided to drop a bowling ball from a height of 5 meters into the mud. Why? Why not? I decided to drop a bowling ball. It's going to fall through the air 5 meters, hit the mud. It's going to sink into the mud until it comes to a stop, half a meter, 0.5 meters below the surface of the mud. My question is, what's the average force of the mud on the bowling ball as it's sinking in the mud? Because the mud brings it to a stop. And the reason why I asked for the average force is, in truth, the force is not constant as the bowling ball is being stopped. So we'll just calculate the average of that, okay? This question is easier than it looks. And if you use energy considerations, it's interesting how quickly you can solve it. The initial speed is 0 because I dropped the bowling ball from rest. The final speed at that point right there, the mud brought it to a stop, and so its final speed is 0. Its initial height, I'm going to measure its initial height not from the top of the mud, but from where it stops. And so that is 5.5 meters up. Okay. Now to solve this, the initial energy plus the net work equals the final energy. Remember that initial energy is KEI plus UGI. Well, the only thing doing any work is the mud. It falls through the air, so there's no air resistance. There's no work there. Gravity, remember, gets contained here, so we don't consider work due to gravity because it's contained in that term. So the only work is the work done by the mud, M for mud. And that equals the final energy, which is final kinetic plus final UG. That's potential energy. Now there's some stuff we can cross out. There's a lot of stuff we can cross out. The energy of its initial motion is 0 because it has none. So it has no initial kinetic energy. The final energy of its motion, the final kinetic energy, is 0 because it comes to a stop once it stops down here. So that's 0. I love to cross things out. And its final potential energy is 0 because it no longer has any height. I measured the height initially from that spot, so that is 0. So YF is 0. So that is 0. Oh, yeah. Potential energy, M times G times YI, which again is going to be 5.5 meters. Oh, the mass of the bowling ball, sorry, is 12 kilograms. Plus the work done by the mud, which is the force of the mud, Fm, times the delta Y, that's the displacement as it goes through the mud, which is half a meter, times the cosine of the angle between, I'll put an M here, between the force of the mud acting up on it and its displacement as it goes down. That's going to be 180 degrees because it's traveling down. That's delta Y. The mud acts against it to stop it. So there's a 180 degree difference there. And that's going to equal 0. We're looking for that. Let's just go put in the numbers. So this is 12 times 9.8 times 5.5. So M is 12, G is 9.8, Y is 5.5. Plus, we're looking for the force of the mud. Delta Y is 0.5. Again, the ball's in contact with the mud for only half a meter, not 5.5 meters, only half a meter. So this is half a meter. Times the cosine of 180 degrees. Again, it's 180 degrees because the ball's going down as the mud's pushing up on it, stopping it. That's a 180 degree difference. And again, it's equal to 0 because it no longer has any speed, no longer has any height. That's where the 0 comes from. Remember the cosine of 180 is -1. Cosine of 180 is -1. Put in the numbers and solve for that. Let me get my calculator. 12 times 9.8 times 5.5 equals that. And then divide that by 0.5. Now I get 1290-ish. So 1,294 newtons. That would be the force of the mud up on the ball as it falls.